I think we're in business. Let's get started. Oops. Here we go. Uh, Morning, Ben. Glad there's other people out there. Hold on a sec. All right. So this was just taken a few minutes ago, looking out my upstairs window out over the city. Sun just coming up. Is it ever cold out there? It's minus 11, wind chill minus 17. I know if I lived in Edmonton, I'd be saying, oh, a nice warm day. But for Halifax, that's cold. Yeah, incredible. I grew up in Montreal, and back then, uh, that this was pretty normal, and we would usually be buried in snow for the winter. Winters were much colder and a lot more snow. Even in Halifax, it was. But I'm old now, so the cold bothers me. Anyway, let's get started today. It's going to keep it probably a little bit lighter. This was a picture I originally had for today. Now it's back in the fall, and Dora was out at Long Lake Provincial Park at sunset. And, it was a beautiful evening, and it wasn't that cold. She wore a bit of a sweater, but it wasn't that cold. Um, Malcolm sent me some photos, and I forgot all about them. This one was from River John. And River John, if you're not familiar, is on the Northumberland Strait, so it would be looking across at PEI. Um, and It's an area I really don't know well at all. Um, and I'm told that the water there is a lot warmer during the summer. And then I'm more familiar with down along the South Shore. Lunenburg County area is more my stomping ground. And there in the summer, the water is bitterly cold. Even at its best, it's still cold, cold. But anyway, it was a nice, relaxing image he sent. Uh, all right. A few bits. I promised you I'd give you some feedback on test two. There's a bit of debate going back among instructors about the test. Uh, Nobody really saw problems with the questions. Um, that uh, Some have been feeling, well, you've been doing so well on test one and on the quizzes. What's wrong with having low grades? I don't like them. Um, in my mind, uh, uh, I should have a certain percentage of students that are getting like 90%, 95%, 100% on a test, particularly if you've got a large group. Um, and so, what are my expectations on what's an A plus? And that seems to settle in around 14 on that test, not getting a 16 on the test. So we're going to mark it out of 14. It still means the overall average, I think, for the 8 sections of this course is only about 60%, which some may feel with a math course quite acceptable. I don't. Um, I like my class averages up in the high 60s, maybe 70%. If it gets above 70, then I figure I probably could have challenged you more, or it's a very small class, or I'd done amazingly good teaching. 60% still low in my books, but as noted, the first test was very, very high. The quizzes are, and I'm going to put a lot more thought again into subsequent tests because I don't want to see a repeat of this. Um, that and a reminder: most of you are participating in the discussions, but I'm trying to have a question for every chapter, so there'd be about a dozen, and you get a point if you participate in the discussion. And so you could get 8 points by just participating in 2/3 of the discussions. I'd encourage you to participate in all of them. Gets you to think about issues. But we'll replace your lowest test score with your discussion score. So if you participate in 8 discussions, you've got an 8 out of 8, essentially, to be able to put towards your test. So um, that's what I'd recommend in terms of trying to fix that issue. And as promised before, the Wednesday before each assignment is due, I'm going to devote the first while to questions on the assignment, and a number have been rolling in, and you may want to post some in the chat. Most of them have been relatively straightforward. It may be the way I express myself in the question. They're doing the stuff correctly. That's not been a problem. But I have been getting questions referred to me by instructors in other sections that there seem to be problems with Macs and doing pivot tables. I think questions 5 and 6 to do with a histogram using a pivot table. Mac doesn't seem to want to let you do it. I tried looking at the version of Office 65 that's in the cloud. It's very, very limited in terms of what it does. But it's strange that we've been doing this now for 4 terms plus the summer. And I know students have expressed frustration because Macs do things differently. But I had not heard these issues to do with pivot tables, and I don't know if you're encountering them. But nobody's joining in with the chat. Are there issues here? Good. Okay, a couple of you are. Um, I'll wait for your comments. You haven't. Okay. So I don't know. I don't have a Mac, and I don't know exactly what's happening with that. Um, and yeah, okay. I haven't heard that before, but I looked at Office 365 in the cloud as a substitute, and then found it was almost useless. You could do almost nothing in a pivot table. It's almost not worth your while. And I'm just wondering if they're using that on a Mac, which, since it's in the cloud, it doesn't matter if it's a Mac or not. Want to caution Mac users. I don't want to discourage you. I know a lot of students have them. They really love them, just like they love iPhones. That uh, when you get out in the business community, most sort of financially oriented business environments will use a PC. Government offices are all PCs. That Macs are very widespread in firms that do marketing and advertising. That ones where graphics and visuals are key love Macs. Those that focus on numbers and that type of thing, they seem to head towards the PC world. And that um, so you will possibly find in subsequent courses that there may be issues between Mac versus PC or getting used to it. Um, as I said, I've been finding most of the Mac users are quite resourceful in finding where do you find stuff on a Mac instead of finding it on the PC. Uh, but it has been an issue with some. Are there questions about the assignment? Um, Not, I'll just walk through a few things that students have asked me and just run through those little things to assist you with that assignment. Uh, don't like you getting frustrated on things, particularly if it's because I didn't express the question as clearly as I should have. So let me go quick and look at this. I had fun doing this, looking at this data set, because there are things that I found a little bit unexpected for me when I was doing it. That the one thing that has come up going through these different ones, 5A, yeah, I'll go down and look at that one. The first few questions I've been getting are the earlier ones, but generally everything people have sent me has been right. Okay, we'll get to that one. Let me go through the first few. Uh, I wasn't, probably I should have said, each question I tried to phrase it so that they were fresh questions. So in the first one, you build a pivot table and it said, what survey in rows, gender in columns. I'll just show you quickly what I did. I tried to make, so here was my spreadsheet. I think this is the right one. Yeah, I think the one you're using. Yeah. And said In inserting pivot table, nobody seems to have trouble with that. It's going fine. You get your pivot table. This one said survey in rows, gender in columns, ID in the values. So just dragging things around. Make it a little bit bigger here. And changing these things to count. Whoops. Summarize values by count. And just ask you to make it into a chart. Boom, got a chart. I did a similar question in the fall. With the fall data, we had a whole bunch of blanks. And so I think later on I asked you to, with gender, to ensure it's just male and female. And didn't realize I'm surprised the first time I've had a file that is all clean in terms of gender. And didn't double check that before I phrased the question. And oh, I'm giving you the solutions. Excuse me. Let me get one that doesn't have answers in it. Excuse me here. There we go. Okay, I'll close this other guy. Okay, so I go on ask and flip it around. The sorry, to format this as percentages and looking at changes here. And frequently that's what you're going to be doing. That, and just to remind you that if I'm comparing 2020 to 2021, those are the two groups I want to compare, then I should go and format this as percentage of row total because it's the rows that I'm comparing. If I was comparing females in 2020 versus 2021, maybe I'd put it as percentage of column total, but it really wouldn't be useful information in that question. But think about what it is that you're trying to do the comparison of. Now we want to look at where they come from, and I don't care about gender now. And this one, students seem to have, they've only asked questions about, they seem to have been able to handle this part well. So this one, you would find, I've got blanks. I want to get rid of them. Oops, get rid of that guy. And all of these places outside of Canada, the numbers are really small, especially this year that we're down an awful lot with international students, as you can see. And so what I've asked you to do is group these ones, and you could rearrange rows and then group, or just go and remember when you're grouping stuff or moving stuff, where you hold your cursor, if it's over on the left, you get an arrow that selects the whole row. Generally, don't do that. Go over to the right a little bit so it's a cross like that. And then you could grab your guys, and other is still outside of Canada. And then I could group them. And then it puts all those ones all together. And remember to collapse the group. There's no sense in making a group if you keep it all together. Rename it, change the scale to percentage, and so on, but just on frequency count. Look at the change in international students. We've lost some Nova Scotia students this year, but massive number of international students, probably because they couldn't get in the country. So grade worry is another one. You're going to end up comparing 2020 versus 2021, and that one seems to have gone up a little bit. And you'll probably look and see with gender, it gets pretty busy putting gender in there as well. But you should see that there are differences between males and females, but still both males and females are worrying more about their grades this year. So questions 5 and 6 are ones where I'm looking for you to make up histograms. So let's look at that guy. Let's drag home out of here. I've got the two survey years. and I'm looking at, was it hours studying? Okay. And in assignment 1, you found that students were studying a lot more hours, a huge number of hours. If I put it in here and I've got count, you'll see my picture here is lots of little numbers. And if you like, we're going to change this. It asks for relative frequencies. Had a few students ask, what's that? So 9 is a frequency. 9 students in 2020 said they only studied 2 hours a week. Okay. 9, is that a big number, a small number? I need to understand it in context. Relative to what? Is 9 a big number? Compared to 10, it's a big number. But compared to 300, it's not a big number. Look at your total, 344. 9's not a huge number. We want here a relative frequency is expressing it as a percentage. So show values as percentage of column total. And I generally recommend get rid of your decimals. Don't have to. I didn't tell you you had to. But as a rule, I get rid of my decimals. That unless I'm looking for tiny numbers. Like if I really wanted to look at that 0 and find out, it's not quite 0, it's 0.1 or 0.2 or 0.3. It's less than 0.5. That 9 I had before, now I understand it means only 3% of the students studied 2 hours a week. So that's what we're doing in the first stage, but this histogram is useless. So with this, go to your category, get it looking like a cross, and group it. Now, before I do that, notice some of the numbers. They go from -9. I don't know how we entered -9. A 0. Was that really a blank? I'm not sure. I don't trust the zeros. So I'm going to say, I would like to group this. And if you do, it should come up with a starting value, an ending value, and an increment size. And I'm suggesting just start it at 1. Go up to 60. That sounds fine. I want to go in increments of 10, though. It makes a little bit fuzzy in the way it does it. It's now going to go from 1 to 11. Yeah. 11 to 21. I just wish there isn't an easy way to get rid of the 0. That was my only problem. And I'm just going to hide that blank row. And you can, nobody above 61, I can hide it too. Okay. Tegan is typing. So this becomes your new and improved chart. And this is, as an instructor, really discouraging. About 2/3 of the students last year said they studied less than 11 hours a week. Not very much. And it's such a huge number of students. I can understand some students don't study much, but to have about 2/3 of the students not studying was discouraging. We still have some that study very little. In my first year, I wasn't a model student, and I probably fit in that group too. Um, that the But there we can see the patterns. Here's the pattern for last year. It's like a ski hill, and then for this year, where it goes up and then spreads out. Okay. Um, so that's the sort of chart I'm looking for you to create. Does that work? Um, okay, we're going to look at that. Zach, there was another question. Yeah, put it, well, it's a column chart. Do you mean to keep the chart as a picture here? Yeah, always be keeping a chart with you. It's, I generally recommend keeping charts when you're doing pivot tables. Um, that visual cue uh, may help you see things that you didn't spot in among the numbers. Numbers are very busy, and the chart sometimes alerts you to things you didn't spot before. So part of this is just habits I'd like you to develop. That if the other thing I asked you to do is do the same thing with grade point average. So if I go back and look at grade point average, before you do it, generally when I've done grouping like this, I find it best to ungroup before I throw it out. And that will become an issue with doing some things with grade point average at times or with filters. So if I look at your GPA, and again, I get my crazy chart, and let's group it. And I'm going to go from 0. The ending value is 4.3. I said go to 4.5. Doesn't matter. It'll go that way anyway because my increments are going to be 0.5. And so it creates these groupings. And I'm just going to hide the blanks again. And so you see the grade pattern. And so you see last year's students, they did well. Okay. That, bulk of the students are reporting at least 2.5 as a grade point average. That's really, really good. And then it sort of tails off as we get to the top end. But your class is reporting really, really high grades. That if you got an entrance scholarship, as many students did, to keep it, you need a grade point average of 3.7. Well, you can see that last year we had about maybe a third of the students saying they were maybe in that ballpark. This year we've got about 2/3 of students, which is really good. Um, uh, yeah, well, I wanted to compare. I thought 2020 to 2021. Let me go back to the question. That they, oh, you've got a good point. I didn't say to split it up and look at the 2 years. Good question. Um, I'll have to revise the grading then to ensure that you can get away with just a single one. I thought since we were looking at change, it would be looking at the 2 years, but you're quite right. I didn't tell you to compare the 2 years. So I'll have to fix that. Um, keep it as percentages, yes, because frequencies don't matter. We've got more students one year than another um, that generally look at relative frequencies. The um, But this is striking because historically most students lose their scholarships in first year. They aren't able to achieve really high grade point averages. And so if what students are reporting is correct, um, that we're going to have a huge increase in the number of students renewing their scholarships, which is going to put big pressure on the scholarship budget. Um, they used to get after me about overspending the scholarship budget. And every time at budget committee meetings, when they complained about overspending scholarship, it's just like, well, I've got good students. What are you complaining about? The only way that I overspend scholarship budget is if student performance is exceptionally good. Uh, they, why are they complaining? Accountants that are more worried about the dollars than about what the institution is trying to achieve. Anyway, this is a huge change. It really is. It's quite striking. I was very surprised. Um, question that was posed is the studying paying off? For this assignment, I didn't have, it was before we did scatter charts, but you could go and do that. Go back to your data, grab um, your, now I'm going to get it the wrong way round. Okay, so let's, if you don't mind, I'm going to copy a couple of things. Okay, I'm going to copy this and grade point average. And actually, I'm going to move grade point average. Let's move over here and go back and get your hours studying. There it is. You can do the same looking at hours of recreation. It really doesn't tell you anything. There we go. And I could go and, oh, let me just, I'm going to make this into a table. Don't mind. Okay. So take these two, go to Insert, Recommended Charts. You can already see it, scatter chart coming up. And so this is how many hours spent studying. Okay, we've got a strange outlier that's at the -9 here. And this is grade point average. And we can say that among those that spend a modest amount or very small amount of time studying, their performance is all over the place. We've got outstanding students and we've got students that are struggling. But those that study a lot tend to be more among the students that are doing well. So once we get up above the 30-hour mark, we do have some students that are struggling and unfortunately aren't successful, but most of them are very successful. And if you wanted to, you could go and just look and see, well, how does it look for this year's class? Whoops, where'd you go? Somehow, oh, I think I lost my picture, but I could do it again. So this is this year's class. So you're all studying much more. But again, you don't see a really strong pattern. um, that Now, some would argue that uh, that was my lazy approach in my first year. I was a very good student. So I figured, I can do it without studying. And so I didn't. I had a very good time in my first year. My first 2 years, I had a very good time until my grades started to go down. They, uh, but you don't see a very strong pattern here. And that last year, if we go and look at that, and again, let's get rid of these. Um, this was this last year's data? Yeah, I think this is last year's data then, and what the scatter chart looks like. And again, it doesn't tell me anything. It was a little surprising, but I would encourage you to go and dig through the data. There are some interesting things in there that they. Uh, I've asked you to look at your averages and look at standard deviation to apply empirical rule. And if I just want to remind you on that, where did I go with my pivot table? Here's the distribution for last year and for this year. Do you think you should apply empirical rule to that data set? When should you or when should you not use empirical rule or have confidence in the results out of empirical rule? Any thoughts? Bell shape. And so this is the blue one is a bell that's been kicked over a bit. That the orange one has been one that just smashed right over to the side. Empirical rule is going to give me strange numbers because I'm truncated on the right hand side. So it's going to give me a range of values that's going to take me up to around 5 or something. It's going to be, well, you can't get a grade point average of 5. It'll give me silly values. And when your data is really skewed, often your empirical rule doesn't work that well. It's great when it's bell shaped and it's very handy. Uh, when it's not bell shaped, I'll still sometimes use it to at least. Sometimes I don't have all the data. I've just got the mean and the standard deviation, and I just mentally try to think of one or two standard deviations out as being high and low. But you'll find it doesn't quite fit things, that it gets messed up. But it's still a good rule to have because there are a lot of cases where our data is almost bell shaped. So, uh, And the last bit, trying to look at, there are huge changes between the 2 years that normally we don't see a lot of swings year to year on things. Um, this year we're seeing a lot of swings on a variety of things. And um, no, I don't need any screenshots there. I just need the numbers. That um, that the screenshot doesn't tell me anything really. So if you found the averages, that's all. But um, trying to figure out why the 2 years are different. We know COVID is changing things in a whole bunch of different ways. Um, and at the beginning of this assignment, we see that it's changed gender mix, it's changed domestic and international. Do you think that might explain some of the changes and patterns of how many hours you study or what your grades look like? You can actually go back and try to just look at the averages if you want for uh, males and females in each year, or for Canadians versus international in each year. Um, that you'll probably find they aren't. You may find that maybe part of an explanation of a shift, but not enough in terms of what's taking place. So it's curious in terms of what's going on here, but we are seeing a whole bunch of disruption in student performance, and if you look into depression and those issues, you'll find similarly a lot of sudden changes that seem to be strange. Um, just before class, since as I said before, I like looking at data. Here's one that just came in my, oops, let me, no, I've got a better shot of it here. That I think I may have mentioned about application data to you before, big shifts that have taken place. And in Ontario, because all students apply through a single center, you can see how the shifts have taken place. And these are changes in high school applications. And I think I showed you some stuff. These are changes we've never seen before of some schools are benefiting quite dramatically and others not. And um, whoops, yeah, where am I? Get back to the right screen here. Where am I? Back to class. And back to, excuse me, that those shifts that have taken place, the data I showed you maybe once before from a fellow that's interested in numbers. He's more of an economist type of background and what's happening in the university landscape. The ones I just showed you were the same data or from the same data source, but this fellow's expertise is in marketing. And what he's commenting on is the belief that if you have to go to school online, and you may want to think about this, if you're not, if you're doing everything in online, then does it matter if it's a small class or a large class? Um, the does the attractiveness of a small school matter, or the impersonal aspect of a super big school like U of T or York? Does that matter? What's happening in Ontario is small schools uh, are seeing huge drops in applications. That because students are figuring in Ontario they're still going to be online next year, and why why go for the small school experience when I'm not going to get the small school experience? Maybe and they're switching to brand schools. Um, Queens, Western, U of T, or McMaster are doing extremely well. And schools that don't have a super strong brand, but maybe have sold themselves on their smaller experiential aspect, are losing quite heavily. Um, and they're also seeing big swings in program mix. And I think I may have mentioned that before, that health, um, psychology has gone through the roof, I guess, in Ontario as a area of study. And again, it's mental health. Uh, so COVID is disrupting the education business, just like it's disrupting a whole bunch of other businesses that may be seeing. uh, it's creating new opportunities for them, or others that it's making their business proposition less attractive. Uh, you got to think about it. I think some schools aren't really thinking about it that closely. Anyway, before I run on, that any other questions about the assignment? Nobody's typing at the moment. If something comes up, put it up in the chat as we go through, and I'll stop and try to answer you. So today I don't have, I'm going to show a bunch of slides from before, but I won't get into Excel today. We will, after the break, get back into a lot of heavy Excel stuff using a different set of tools. But we're making this transition from exploring data to looking at relationships among variables, and from that, that's our segue into building models. And the data set we're going to use is for Chapter 6 and Chapter 7 is the same one. It's this credit card data. And as I said, it's simulated data, and it has different characteristics of customers and what their balance owing is. That uh, for your next assignment, I'm trying to build a real data set for you. So it's not simulated data, but to address similar types of questions on exploring these relationships. So there are a bunch of different things that, and I suggested to you building a model or to predict balance owing. And that sort of puts the cart before the horse. Why am I talking about the model before I've asked what the questions are? So back up. What are the questions? That question may be, is there a way to identify unusual balances? So then I'd have to define what is a usual balance for that sort of customer. So if I could predict what the balance should be under normal circumstances and I observe it isn't, and I'm looking for cases where my predictions are very wrong, for bad predictions, I'm intentionally looking for them, then that might be the application. That's where I might need this type of model. But sometimes these models we're going to build, not everyone that does prediction also tells you, if you study the model, what are the things that are causing things to happen? What are the factors that seem to affect it? That the maybe it isn't unusual balances. I'm just looking for, how do I identify who are the customers that borrow a lot or borrow very little? I'm looking at really at a classification problem. And so how do I identify them without necessarily knowing their balance? Could I identify them at the time they applied for a credit card? Someone applies for a credit card and I think, hey, this is going to be a great customer. They're going to borrow a lot. They may be a risky customer. How do I do that at the outset? Or someone has applied, this customer isn't going to use their card. They're probably going to cost us money, not make us money. What should we do with that customer? That um, getting insight, it may come out of understanding your model. If you did Quant 1, the very beginning of that course was doing break-even analysis, which was building a model to help you understand the relationship between price, unit cost, fixed costs, number of units you're making, and your profits. And the model allowed you to do what if type things. So it would understand what's taking place. And that's generally what we're trying to do with models. The way we did it when trying to understand customers is we started looking at comparing balances across groups. And I put risk into different groups. I did a box and whisker chart because that was a tool we had just explored. And we found those that have low risk seem to borrow more than those that have very high risk. We may then want to, why do they borrow more? Or why don't high risk people borrow? Understand what's going on there. So it may be that the answer to one question uh, leads to another question. So understanding who borrows, then you're asking, but why do they do it? Um, and we looked at different ways of showing that information and the scatter chart. We'll use scatter charts probably more, but we'll still use box and whisker in certain cases, particularly when we're comparing groups on a numeric variable. And scatter charts we'll use when we've got numeric variables predicting numeric variables. But we'll use both. We looked at the patterns across the different variables. We look at correlation as a way to measure strength in that. But as we start looking at it, we see, okay, certain variables may be important, other variables not. But you're still starting to think about how you might be going about doing prediction. And so getting back to what's a model, and in Quant 1 and in most courses, models are presented as formulas, and that's the way we're going to start. As we work through, particularly when we get into classification, you're going to see models that have no formulas, not directly anyway. Um, that, but I'm thinking what a model is, it's a representation. So you could think of sometimes a picture could be seen as a model. I'll show you a chart in a minute that you can think of as a model. Some that when trying to imagine a building, when we were building Sobe building, which you've probably not seen because you haven't been on campus, that uh, we got the architects to give us renderings, pictures of what the building would look like on the outside. And we worked through blueprints, a lot of big blueprints, to try to understand how that building would be configured. If you've been in the Sobe building, uh, the entrance has a big atrium sort of thing. It's open up on higher levels. It took many of us a long time to actually visualize what they had created in terms of a lobby from blueprints, because we had a blueprint for the basement floor and the main floor and the second, each floor. And but they're slices, and I wanted to look across all the slices at once. Couldn't do that easily within that. Now, today we've got software that could allow you to visualize those sorts of things. But 25 years ago, we didn't. And it was really challenging to try to imagine what that building was going to be like. But these different things, these are models, are not exact. And like a blueprint isn't exact. So it doesn't show, it showed a lot of detail on some things, but it didn't on others. And that's the way models are. What are you trying to understand? So with data mining, there's at the beginning of the course, we talked of about 10 or so different applications or modeling situations. Profiling. A profile is trying to create a picture, a profile of what does that serial killer look like? What does that really good customer look like? What is an awful customer look like? And defining those sorts of things. Building models that described what things go together. That what if they've got this, they have to have this. Yesterday, I had to buy a new printer, and immediately it suggested buying toner cartridges. It's a laser printer. So they go together. When you buy one, you'll probably need supplies to go with it. That um, and so building models about which things should you combine together. That which ones are most likely to, and which ones are sometimes or unlikely to. Clustering, things that exhibit similar characteristics. Uh, I think of clustering in terms of market segments of that clustering customers. But and some of those clusters are not uh, in data mining. Clustering is done by the data developing the clusters, as opposed to you starting out at the outset and saying, "Oh, I'm going to group all African students together as a cluster." Um, Africa is a very big place, and they're very diverse. Even Nova Scotia students, that uh, they are very diverse. They're quite different depending upon where they're from. That the I may have said to you, and if you're from Halifax, we have Citadel High now, but before that we had two high schools um, across an intersection from each other: Queen Elizabeth High School and St. Pat's High School. And you might think, well, they're the downtown Halifax high schools, so they're the same. No, they were two very, very different clusters in terms of students could apply to go to either school, but the student mix and values, attitudes, and the like were very different between QEH and St. Pat's. I had a daughter that went to each school. It was quite interesting to see the difference. Those are clusters where the students formed the clusters. They chose which school they went to based upon where they thought they would fit in. Similarity of matching is in things to do with identifying those similar characteristics. But trying to define the similarity we're going to find later, like if someone says, oh, you look like your father or you look like your mother, what do they mean? How do we measure similarity? Can you actually calculate it? Well, if you're going to do similarity matching, you're probably going to have to find a way to do that with a formula, maybe. Causal modeling, we will do that along the way with some of the models we're going to be doing. But each of these ones are uh, that called unsupervised learning because I'm not setting a target about what I'm trying to achieve. We're going to focus much more on the other ones where we're trying to make predictions, and that the predictive models often are ones that more inform subsequent decisions because we're predicting an outcome. And so if we do this, this will happen. So informing those decisions. And so that would be value estimation. And that's the first one we're going to look at, where it's a nice formula type of thing. And then classification. Value estimation is one we're going to go into very deeply into one particular tool. With classification, we're going to look at probably 6 or 7 different tools at a very high level and show you how different they are. And some involve formulas and some don't. Um, that there are different approaches being taken. Link prediction, we're not going to get into that one. Say value estimation and classification are far and away the most common predictive models that are used. And we call that supervised because we're going to train to be very good at predicting an outcome. So they're supervised, they're trained to learn. So here's a model. And so this is just a simple model of how they, uh, to some extent, I used it in terms of dealing with students and trying to recruit and retain students. So there were prospects out there, potential students in high schools or the community or wherever, and you would send out types of messaging, advertising, recruitment events, open houses, various types of things. And some of the prospects then respond. We'd call that acquisition phase. And then some of those we were able to convert into students. Like if you're a new student this year, you became a new customer to St. Mary's. And so you start, we say we've got a funnel. We start with a lot of prospects, smaller number that respond, and then in a smaller number that become real customers. And then they become established customers. They come back for second year, and we hope to keep them. Along the way, we lose some. They drop out, or they're pushed out, or whatever. Some of them, they graduate. And with those former customers, you want to bring them back in again in some fashion and make them established. Um, that this happens frequently with if you've got a subscription service like a smartphone contract, that you may switch providers, switch to someone else, and your original provider may try to make efforts to bring you back in again and make you an established customer again. And So we have all of these phases that they work through. And this is a model of that sort of cycle that we go through with a customer. And there's acquisition is a busy area. That's our recruitment team that we don't do a very good job, I find, on activation. How do we handle the first year and keeping that customer so that they renew their subscription, they come back into second year, and it's fuzzy as to who's responsible for this relationship management in here. But if you were looking at it, and you may want to break it down to the different phases, what are the things you'd think about in acquisition? So what are the questions that, um, how would I identify good prospects? So there's a lot of potential customers out there. Do I spend all my effort in trying to send messaging out to everyone? Or do I, um, uh, and when I first ask the question, what's a good prospect? I may need to come up with a profile of who is a good customer, who would I really like to attract. That I may have clusters of those, my really good ones, and then other ones. Maybe I've got different clusters of customers, of which some are most desirable and some are least desirable. But I'm going to try to identify that in advance. And when I'm talking about a good customer, I have to define what is that. From a purely financial point of view, it's a target audience, but we've got many target audiences. Okay, that there isn't just one. And for some people, a good prospect, it's going to be this student that gets outstanding grades. Yeah, okay. Um, from a financial perspective, I'd say I want a student that comes back, that it's going to be a recurring revenue stream. Okay. Um, that and that may not be the one that gets the highest grades. Uh, honestly, grades are just an intermediary assessment thing. I would like a good prospect is someone that turns out to be a successful graduate. And then you have to define, well, what's successful? Well, um, that may be defined by the student, or by the graduate. It's one that has a job they enjoy, and maybe it's one that has financial success. Maybe it's one that comes out and has a whole host of new friends and relationships that gives them a fulfilling life subsequently, and that's success to them. Uh, but what do you mean by those? And different people define it differently. If I got to reach the prospect, channels are incredibly important. That was often the frustration for me in student recruitment because we have very few channels. I can't, in the US, almost all students are expected to write a, uh, a test, aptitude test to get into college. And there are two different ones that are frequently used in the US. And uh, since almost everybody goes and writes these tests, and most states go and require the students to write the tests at graduation, uh, you can buy lists. So I could go and say, I'd like um, students from Massachusetts that are female, part of a visible minority. Those are things they could legitimately ask, and have test scores in the following range. And they'll send you a list and their contact details. And so you can do direct solicitation to those particular students. We can't buy that type of information in Canada. That's very private. It's not in the US. That, but you have different channels, and when I started heavily into working with student recruitment, it's as the web was taking off and moving our recruitment strategy. How do we move it online? And then what are the channels that we use? So where would we place ads? And that's evolved quite dramatically from at one time as you had to pick very specific things. Now there are a lot of different options available to you in terms of where you post ads. But thinking of the channels you're going to use. and which ones are best to use. And then can I measure best in terms of maybe response rates? And I may be interested. We'd get ones where we got a lot of response, but they never turned into real customers. They never enrolled. So how do I measure payoff? There are things to do with the messaging we use on different channels. Think about all of these. You can't answer any of them without data. You've got to collect data, maybe do experiments and collect new data and evaluate that type of thing. These are all data mining questions that I've got here that at first thought you may not have thought of them as data questions. Um, we frequently deal with all of these sorts of things, but regrettably, a lot of people think they know the answers and they don't go and check the data first. And you get surprises, like looking at what's happened this year with you as students. Um, some of the stuff in the data is a surprise. That it's critical that your decisions and the way you're operating are grounded, are evidence based. They'll say it means they're data based, and so it's important that you've got tools to go and do that sort of thing. So there's a whole bunch of these that are data mining applications just for when you define a problem, one problem. I want more students. I'll end up with 20 questions that need to be answered. And when I answer many of them, it just generates new questions for me that I, again, need more data to answer. So um, a business problem may be easy initially to specify, but as you drill into it, you're going to find that there are a whole bunch of different questions that are asked, and then they become, if I go through these ones, which channel? That's almost a classification question. What's the most effective one? Similarly with messaging to some extent, these ones are more like value estimation because I'm trying to calculate numbers or measure the payoff. Again, it's a value estimation thing. Back here, I was doing some profiling, but along the way, some of these may involve to make them effective co-occurrence groupings. That this is a better channel if I do this with it. You combine certain things done in combination. That so there are a lot of these ones that we're going to be going through, and a lot of them we'll find involve the term similarity. And so, although it comes up in clustering, similarity matching, link prediction, it'll also come up in classification problems and maybe in value estimation ones. So, with value estimation, um, that's what we started with. I'm trying to predict balance. And I'm starting out looking at scatter chart and look at correlation, but I want to move forward into something more concrete. That they aren't models. They aren't going to tell me the prediction. So even if I said that credit rating is going to give me a good idea of the balance, how? I need a model to be able to pull that off. So a model, think of it as a formula, a function. I'm predicting balance, and it's some function of customer characteristics. So in a very abstract sense, I do it that way. What's the formula look like? The formulas can get very messy. If you did quant one, you did a lot of simple linear ones for linear programming and that type of thing, or break-even analysis. But you had some messy ones, like in finance. If you wanted to determine what's your biweekly car payment on that car loan, that formula was quite messy and involved. If we're building them from scratch and we really don't know what the relationship should be, we don't have a theory. In finance, we've got a good theory as to how interest compounds. Then start out generally simple. And the simplest model is the straight line, like you used in break even. So it had a slope and an intercept. Okay? Start there and then make it add complexity. That's my general strategy in terms of doing these things. So We have X and Y. Y is what you're trying to predict. We often call it our target variable or our dependent variable. We're going to train our model to get really good at predicting the target. And then X represents those variables that help us do that. And if I'm just using one, then I'll probably pick the one with the strongest relationship, which was credit rating in this one. So this would be the sort of formula I've got. And so I've got this thing here. This is my scatter. And as I mentioned last class, we're going to put a straight line through it because that's what that formula was. It's the formula for a straight line. And so how do I pick the best line through it? And there you've got to think about, well, what's your objective? Best in what sense? What do you mean by best? Well, what are you trying to achieve? Well, I'm trying to predict credit card balance. So best would be the line that gave you the best predictions of credit card balance. So best predictions, what do you mean by that? They're most accurate. What do you mean by accurate? If something is accurate, then there isn't an error. It's exact. So I'd like to have the smallest prediction errors. That may seem obvious, but I'm just trying to lead through. Make sure you understand your reasoning and you understand what your objective is clearly and that you're doing this to achieve that objective. But even that one isn't straightforward. So here's a bunch of dots. I put a line through it, and none of the dots fall on the line. They're all wrong. My predictions here, it's wrong. Prediction here is wrong. And this one is wrong. They're all wrong. And the length of those blue lines is how big the error is. So these were good predictions because the line is very short. And that one is good, very short. And this one was bad. Its line is quite large. So I don't like large errors. And if I have to have errors, I'd like them to be small ones. That are they all the same though? If you had an error of 20 or an error of 10, so you're off by $20 or $10, is that twice as bad? If it is, then we're saying that there's a linear relationship between the size of the error and the consequence to it. Because if your prediction is wrong, something happens. What happens when you make a wrong prediction? If I was forecasting sales and I forecasted sales of 1,000 units and the actual demand was only 600, what am I going to do with the 400 that are left over? It's going to be a cost to me. What do I do with them? What's the consequence of that? If I predicted 1,000 and I had 1,500 customers come in, then I've lost 500 sales. What do I do there? Do I give them rain checks? Do I promise them I'll get them next time? What happens there? Do they get upset with me and say I'm never going to shop at your store again? What's the consequence of that error? Every time you make a mistake, there's a consequence to it. And if it's a small error, most of the time, yeah, no big deal. I expect that. I'm ready for it. The big ones, we worry about. It's why you take out insurance. That if you take out insurance on your car and you've got a $500 deductible, you're saying if it's a small damage to my car, $500, I can manage that. But if I total my car, I can't afford that. That's just beyond what I can deal with. That's why I have insurance to deal with that sort of thing for the really big expenses. So in those instances, we're saying small ones, the penalty to me is small, but big ones, the bigger it is, either way, the bigger the penalty is. So maybe squaring the error will penalize the bigger errors. So being off by $20 gives me a cost of 20 squared, 400, whereas being off by 10 is just a cost of 100. So 401. So that 20 error versus a $10 error is 4 times. It hurts me 4 times as much as the other one does, not just twice as much. So squared error is sort of nice. It also, it turns out, it makes nice math. And the most common practice is to find the line that minimizes the average squared error, mean squared error. So we don't look at absolute value of predicted minus actual. Just get rid of the minus sign, that sort of thing, like deviations from the mean. Just like we had deviations from the mean and we ended up squaring them before to get rid of minus signs. Well, we're squaring again so that we can use calculus. So it's minimum of prediction minus actual squared and averaged out. And we call it the minimum mean squared error, or some call it ordinary least squares, the least squared value. And it's in that sense that it's the best line. And this is the most common strategy used for finding a straight line through a scatter. There are other strategies, some that give more weight to more certain errors than others. Some that will look at absolute value instead of squaring it, that they don't think the penalty should be of a squared nature. There are a variety of other tools, but the most common one is to use this ordinary least squares or minimize the mean squared error. It's important just to have a sense of you're not going to have to calculate these things. That it's too messy to do by hand. But think about, why is this the best line? And what could potentially influence my line? Some people like to write the true line and use Greek letters, beta. Beta is a B in the Greek alphabet. And they say that the actual balance will be some starting value, an intercept, a balance when your credit rating is 0. And then there's beta 1, which is the slope, how much your balance should increase as your rating increases. But because we know the points don't fall on the line, there's going to be some noise present. But the noise I can't explain. I'm trying to explain that underlying pattern, but the noise I'm leaving there. The way we would usually do it is not estimate the noise. We estimate a line. And so sometimes you'll see the notation. And if you're doing a stats course, you'll see this. They'll use lowercase b0 and b1 for the intercept and the slope. And they'll often put a little hat. If you see a letter or symbol with this little hat over the top, it usually means it's an estimate. Okay? So just notation that you may encounter. I'm not going to be using this to any extent, but when you take statistics, you will be using this sort of notation. And so Excel will calculate this for us. We're not going to do it today, but Excel will grind it out and we'll look at the output from that. The formulas, it's nice that we can actually get nice compact formulas out of this to find the best line, but they're still tedious to work with. And that what I do want to emphasize is that this is an estimate of the true line, and our predictions are only of the average balance. So this is my estimated line, the red one here, and it's just on average what happens. And always remember that what actually happens can be higher or lower than that. This is a prediction. All predictions are wrong. That it's what you think is most likely to happen, but what actually happens is always higher or lower than that. That it's almost impossible to make a perfect prediction. Good predictions are ones where the deviation from the line, the distance above or below, is relatively small. And also remember, just like when we were studying averages and other things previously, since it's based upon just this sample of 400 customers, this line isn't perfect. If I had a different group of 400 customers, I would probably get a slightly different line. This is only an estimate. And so the line isn't perfect. We're going to find it could wiggle a little bit, hopefully only a little bit, and it still will give us reasonably good predictions. But always remember, anything that we're calculating from data is an estimate, and will often then be challenged as to, is it a good estimate or a bad estimate? And we need to be able to respond to that. We will later, that we won't get into just yet. So this is sort of a theory type class as to what we're doing. Generally, though, to take data and turn it into actionable knowledge, stuff that we can act upon, we need a model. And that there are generally behind every one of those data mining applications some type of model, not necessarily a formula, but something that we can define as a process, as a model that was there. And we're going to look primarily at predictive models. They're generally the ones that are most fun. And we're starting with value estimation. We're going to start with a very simple straight line. We're going to try to make the best straight line from it and make sure that we understand what that is. So I'm going to show you in the next class how to do it, how to interpret it, how to understand the accuracy of the line and accuracy of the predictions. So that how much off that line could be, that's one thing. May not be that important, but very often we want to know how far off could our prediction be? And if you think back to that scatter, the predictions aren't all that great. And we're going to work at then saying, well, if isn't good enough, how do we improve the model? And what process should we go through to make it better and better? And at each stage, evaluate how good it is. So that's where we're going, but we're going to leave that till after the break. Um, and if you do have questions on the assignment, I will try to turn around answers relatively quickly. And other than that, I think we're fine. And we'll call it a day today. And I hope you do have a good break. And don't forget, you do have a Chapter 6 quiz on Saturday. And there are some of you I am going to be following up with about other things that you may have missed, past quizzes, first assignment, other sorts of things. So over the break as well, I'll be playing catch up on what to do with students that have missed things or run into trouble in the course so far. Okay. Take care. Enjoy the snow. Um, and you'll see me again in almost 2 weeks. Bye now.